RBA's Business Research Academy welcomes to you in the second part of the video lecture number 14. In this lecture, I'm going to discuss about the assess the significance and the relevance of formative indicators. Earlier in the part one of the video lecture number 14, I discussed about the assess convergent validity of formative measurement model and assess the formative measurement model for quality issues. So this is the second part of this one. Dear friends, we talk about the significance and relevance of the formative indicators. So these we can get with the help of the bootstrapping technique, because smart PLS is a non-parametric technique, so that's why it's not giving you the results of the formative indicators when you are running our model. But for additionally, you have to use the bootstrapping technique. So in this regard, now we are going to start our work on the bootstrapping, how to do this one in the smart PLS. But before this one, I want to introduce myself. My name is Dr. Rahim Sumro from Shabati University, Pakistan. Dear friends, I have also earned this software from the Smart PLS Academy, Hamburg University, Germany, from where I completed these 9 modules from the Smart PLS Academy. So let's start our discussion. So first of all, this is a pretty clean our interface of the Smart PLS available, and here some of the models are already available there on which I will work. So first of all, what should we do? That we have to bring our model. So we have to work on the model infected influencing on the restaurant. Okay, double click it, and this model has been appeared over here. And then we are going to start some calculations work. Dear friends, the model is available here. So in this one, some of our variable, all our latent variable are the reflected. First, we have to convert them into the formative. Just click on this one, right, and a switch between the formative and reflective are alternatively Alt Q, and then this has been changed. This has also been changed, and lastly, service quality has also been changed. Now we have the reflective, and some we have the formative. So now we are going to apply the model, initial model, consistent PLS algorithm, because some we have the reflective latent variable, some are the formative latent variable. That's why the consistent PLS algorithm is more suitable than the PLS algorithm. Just click it. Okay, it's better to keep the check over here. Its benefit is what? That for example here, this statement, the Hansler and the associate writes here that the advise us to connect the connection between the all latent variable. LVs mean all latent variable for the estimation of the path latent variables score to get more stable. So the benefit is that you will get more stable results if you are going to create this type of put this type of check over here. Okay, nothing, all the other things are okay. Just start calculations. Now that we have got some of the results like the AVE. Okay, so now we're going to check the AVE. So okay, there is so many type of the violations of the AVE. All the values of all the indicators are below the 0.3. And if you become more liberal, then the 0.5. So 0.5 is okay. Now we are going to apply our consistent bootstrapping. Okay, now what to do? Then again, come in the here in the factor, and then calculate, and then come again consistent bootstrapping. So now the options have been opened right now. First of all, setup, leave it. Okay, bootstrapping. So first thing is that if you follow the default, okay, but you should make some changes in that one. Which other changes are there? Okay, some of the changes are there. For example, here the sample size is a 500. So 5% sample size is enough when you are working on the exploratory research. But if you are not working in exploratory research, then probably you should have a larger samples, like the bootstrapping samples, like the 2,000, 4,000 and above this one. Okay, here some of the guidelines are there regarding the subsample. Here subsample guidelines are there. Then in bootstrapping, subsample are created with the objects randomly drawn from the replacement from the old data set. That means the what it software is doing. So software is doing the randomly making depending on this range 5,500. These are subsamples for you, and then it provides some of the results to ensure stability of result. If you want to have a stable results, then the number of subsamples should be large. For initial assessment, one may use smaller bootstrapping like the 500, but here it is recommended that the 5,000 should be used if you want to get a stable results. Now, the problem with the large sample size is that it takes much more time. For example, if you are selecting here just like the 5,000, then probably it will take 5 to 10 minutes to calculate, to complete all the calculations of the subsample. But if you are focusing on the 500, then within the 2 to 3 minutes, it will complete the whole process. So as this is a video and we do not have sufficient time to work on the large sample size. So for practice purpose, I given the 500 sample size, but in your free time, you can give the 5,000, 10,000, 2,000. And one more thing is that I have also putting the like the link from which you can download the data and project on which I'm working. In your free time, you can do all these things. Another thing, important thing is here, there's about the two-day parallel process. And what is the benefit? That means that the benefit is that it can provide some of the good benefits, like if you come down, then the two options are available. Basic bootstrapping by default, it will remain checked. Okay, and it provides you some of the path coefficient, indirect, direct, total effects like up to this level. But if you are going to select the complete bootstrapping, then it will provide you not only the path coefficient, indirect, direct, total effect, but along with them some of the AVE, composed reliability, cron for HTMT, all these. So that's why I think you should focus on the complete bootstrap rather than the basic bootstrapping. And another other things are advanced setting, where you are finding the three options are available, and a percentile bootstrap, standardized bootstrap, and bias corrected exam. So here, there is the what is suggested that like they have set the bootstrapping method for estimating non-parametric confidence interval. So now three things are available there. As a default, we advise, that means the software developer, they're advising you to choose the bias corrected and accelerated BCA bootstrap, as it is the most stable method and it does not need excessive computed time. Now, two benefits are there. It's a stable method, and apart from this one, it also not require additional time. Okay, one more thing, the test type, one tail, two tail. My test is one tail, and the significance level, three significance levels are there: 5%, 10%, 5%, and 1%. So I'm focusing on the 5%. Okay, this is somewhat about the detail about this one. Okay, and remaining things, leave it them is just start calculations. It will take some time. Dear friends, our calculation, bootstrapping calculations have been ended. And now it is about to finish everything about the bootstrapping. Okay, so now we have got results of the bootstrapping. So first of all, you're looking here, that's about the path coefficients. So these path coefficients are normally, here you're looking here, the relationship. So these are our path coefficients. Okay, so the relationship between the one construct with the another constructs, so these are our path coefficients which are looking here. And then what we are interested in the bootstrapping. So now these are relationship p values, some of the significant or some of the not significant, but we are interested into the outer loadings. Basically, you are finding here the outloading and outer weights. Outloading, we check outloading when we are working on the reflective, and when we are working on the formative, then we have to choose or check the outer loadings, outer weights. So now we are opening the outer weights. Okay, so but before this one, we should check the AVE. So normally all the AVEs are within the range. So that's good thing. So now if you are, the minimum value is 3. So now all the values are less than the 3, but if you become somewhat some more liberal, then I think the 5 is okay. Even if you want to become highly liberal than the 10, but okay, 5 is okay. Now we are coming here. So now we have the outer weights. These are our outer weights. So here we are looking here that these are the p values significant. On the best of these p values, we claim that our certain hypothesis is supported in certain hypothesis is not supported. So there are the three violations are there because their value is more than 0.05. So that's why all the violations are in the red color and the remaining things are in green color. There, when there is no any violation, all are in the green color. Okay, so now let's move how to remove these violations. First of all, look, that is the where is the highest violation, where the highest number of the number. So now probably this is the QPE2. It's the name of the indicator, and the QPE is a name of the construct. That means the QPE2 indicators is value is higher than 0.05. So now what you do, we have to reject, we have to retreat from here. So go on the model and find out the QPE2. This is the QPE2, okay? And then outrightly delete it. And then once if you get your indicator deleted, then all the process, that means that has been removed from this. Then again, you have to complete the whole, initiate the whole process. Then again, I'm going to initiate it, calculate it, and then just go into the consistent PLS bootstrapping. And a good thing is that same all the things remain should same and just start calculations. It will take some time. Dear friends, our calculations are bootstrapping have been ended and is finalizing the calculations. So our calculations have been finalized. Now we are looking again, the path coefficients are there, but we are interested in the outer weights. When you open the outer weights, some of the still violations are there. Just two violations are there. Okay, Q food quality 5 indicator, and another one is a QPE quality of physical environment indicator number 4. So these two violations are still there. So we have to read all of these ones. First of all, we have to go on the QPE3. Okay, QPE3. Okay, this is the QPE3. We have to read it. Okay, just the same thing has happened, and then again we have to calculate. Dear friends, when you are going to read any indicator, so again you have to initiate the same process to calculate the bootstrap. So now we have to wait until for next 1 or 2 minutes. Okay, dear friends, another calculations have been completed by the smart PLS, and the things are being finalized. Also, we do not have any more violations. Okay, then just quickly come on right outer weights. Okay, again, one more violation is there. So again, we have to read it. Okay, FQ5, FQ5. Okay, read it. Okay, now one more thing I want to share here, that now we have this QPE lateral variable with a 2 indicator and the full quality also with the 2 indicators. So now that is the beauty of the smart PLS. Even it gives you the complete result when you have only one indicator for one lateral variable. But the same is not applicable in case of the species MOs. It only provides you the results when you have at least 3 indicators with the one lateral variable. So that's a good thing of the smart PLS is there. Again, we have to follow the same thing. Just quickly go there, bootstrap, and everything should be same. Just start calculations. Dear friends, our calculations have been completed and the things have been finalized. I hope now there will be no any issue with this one, at least issue of the violation. So the results are there, and then just quick outer weights. Okay, and okay, outer weights. Okay, now there is no any violation, and all the things are within the range. Range is a 0.5, 0.05. So everything is okay. Now, these are the results which we have to report in our research paper. How to report? I'm going to guide you how to report. I have actually 2 research papers which I want to show you, and through this one you can report this one. Dear friend, these are the 2 research papers which with which I want to introduce you. The first one is a factor affecting the green entrepreneurship intention in business university students. Okay, this is what just for the to know how to report our research results of our research, especially the result which are getting out of the bootstrapping. Okay, now this abstract introduction, and then go back literature review, Theory is also there, and a theory of social, okay, and then directly we have to go on the our research methodology. Okay, this our research model is there, and this is a sample size data collection instrument. And okay, the good thing is there that it provides you some of the good justification that why they have used the smart PLS instead of the covariance based statistical equation modeling software like the MOS, like the M plus, like this one. So the good justifications are there. In your free time, you can read these justifications, and then if you come down, then again further more justifications are there that are why they have used smart PLS. So this is a good way to write down that is able to justify your everything, because in social science everything we do not have the exact rules, exact laws. We have some of the justifications, some of the logical things are there through which we justify our choice that why we have chosen some of the particular thing. Okay. Likewise, smart PLS, okay, and then we are results. Reliability, then you are looking here some of the results of the Cronbach alpha along with their range. So good thing the range is also given here, okay, and a validation of the smart PLS. And then the factorial things are there: compose, reliability, variance, expected. So these things I've already discussed in the video number 13, video 12. That's on the reflective measurement model. Okay. And then this is the detail about all the questionnaire. This is the discriminant validity. So I've discussed, okay, you are looking here the discriminant validity of the service scale through the formal Larker criterion. And then we are reaching on our desired thing. This is a bootstrapping. So now some of the good detail is given here, bootstrapping, and here the authors have used a 5,000 times bootstrapping. It is taking much more time, probably 10 or more than 10 minutes. But for the practical purpose, I have just used a 500 sample, 500 times. Okay, the p value is your 1.01, that is 90%, but I'm referring the 95% because most of the time we refer by 95%. So these are some of the results are there, which they refer, like that. It seems exactly the scale, original, and all these things. I'm showing you from where you can get these results. The same things there. Now you're looking image here that this table. So these results have been taken from this one. Exactly the same. You can export these results. You can export in the Excel format. You can export in the R format, but subject to having the license. Let me say license. If you are using on the trial basis, like the student version, then probably you may not be able to export your result in any form. Okay. Now we are going back. Difference. So these results are there. Okay, on the basis of the p-value. Now, on the basis of the p-value, they will decide either the particular hypothesis has been supported or not supported, along with these other t statistics. So this is the on the 0.01. So now it is not on the 0.05. So in case if you are working on the 0.05, then the t statistic minimum value should be 1.96. If there any value of the p value of any your scale, that means like is for example, if the p value of any scale relationship path value is less than 0.196, then means that the same hypothesis is not supported. If more than the 1.96, it is supported. Okay, and then how they are reporting. So this is the results of the path model. Now, for example, if we are working on hypothesis 2, okay, now it is educational support for developing the interpretation. There's a positive influence on interpretation self-efficacy. This is our hypothesis, and then educational support for developing interpretation has a positive influence on 0.296 for intervention. So now the resultantly the hypothesis has been confirmed. So now from where they have arranged 0.296, that's very easy. Just go here. Here. This is the 0.296. This is our construct educational support for developing interpretation, and the authors want to check the impact of this on this one. So now this is the relationship between. Now this is a like the positive as well as significant on the basis of that p values like that one. Okay, this is one way you can report your results of your bootstrapping. Another I want to show you. This is also very good, very interesting influence of the stress of the technology on academic performance of university students. So it's also a good paper. And by the way, I have provided the link of these two research papers behind this video. Okay, and quickly we are going on our desired results. Now this is a model. These are hypothesis, methodology, data collection. Okay, and then results are there. So now you're looking the Ron Alpha, and the range is also given here for composite reliability, and AVE of the every your scale is provided here. Okay, and then the distributability of through the for marker that is also been established, and the bootstrapping. One here you're looking, the one complete paragraph has been provided here, and again this has been checked on the 90% confidence interval. Okay, and then come back the same table which I showed you in the last paper. The same means the values are here. Okay, and this is the relationship between the two you consider this and the relationship between the any of the two constants. Okay, and this is the p value, and these are the t statistics are there. And then this is the complete model, and this is the path analysis impact of the social overload on the techno stress. So techno stress is our dependent variable. And then if you move down, these are the hypotheses. So now the same way they have tested the hypothesis, that the some of hypotheses are supported and some of hypotheses are not supported. Dear friends, at the end of this video, I hope this video has become much more fruitful or helpful for you. And I also am thankful that you have watched this video at the end. So very soon we will meet in another lecture. And till that time, please take care of yourself and take care of this channel, because this channel needs your support, and support in the way of the subscribing it, in way of liking, leaving some of the comments, and referring these ones to the dear friends. Thank you very much for your time.